to talk about one of our newest release that's going to come in our toolchain, the TT helper, which fundamentally is a Chrome extension that helps facilitate the process of adopting trusted types. And so I'm going to try to give an introduction of what the tool is, how it works, and how you could use it basically to go faster and being more efficient in your adoption process. As I said, it's just a Chrome extension. But the question is, how does it help and why do we need help? So we know that the trusted adoption process is not necessarily simple. It can be quite tricky depending on the application. And there's a few parts that are more or less complicated. The first one is you need to be able to enable the trusted report only header across your entire application. That's not necessarily the hardest, but that's like something which is necessary to start anything. The second piece, which is probably the trickiest, is being able to understand the root cause of the trusted types violations that you're going to observe. And that's where we really need some help for developers, where I guess it can be very obscure. You can be so you can suddenly see a wave of violations in applications without being able to trace them back necessarily easily. And the last piece here is not necessarily, I mean, it's kind of optional, but could be very useful in a lot of cases, is if you want to set up a default policy, and I'm going to come back later on what this is. It can be particularly tricky, especially if developers lack knowledge around what default policies are, and they generally do, because it's a little bit more, I guess, it's less known than everything else in the trusted type spec. So how does TT Helper help? It first enables trusted types in report-only mode, and we'll see how it does it, but transparently for all the users of the application, or I guess of the extension. As a second step, to help understand better the root cause of those violations, it will cluster the violations together with the same root cause. So again, that straight away should allow it to go way faster in understanding where the violations come from. And finally, it provides a way to have a working default policy to remove all violations. I'm going to come back on what default policies are, but what there is to say about that is that it basically does 80% of the work around default policy implementation for developers. But first, I think it's worth coming back on what trusted types is and how it works. Some of you might already know that, so I'm going to give a quick debrief. The idea behind trusted types is fairly simple. It's at the end of the day, it's simply a security header. So as you can see, it's kind of a subset of CSP, which comes with a specific value. And what it does, you can see that in the second screenshot, is it instructs the browser to reject basically any dangerous dumb API call right away. So here there's an attempt to perform a raw inner HTML call, and the browser is simply not going to execute it when trust types is enforced. And here again, those dumb APIs are often the root cause of dumb XSS. And so trust type does the job of covering all of them and rejecting any unsafe call. But what if you still want to use those APIs for some reason? You have the possibility to implement what we call a trusted types policy. And so that's the second part, which is important to understand, is you can still, we recommend obviously moving away from those calls, but if you still want to use them, you can. It's just going to be a more opinionated decision by the developer with trusted types, in the sense that they will have to create this policy that comes with the trusted type API. And when they create a policy, they obviously want to make sure that the input is safe. If it requires sanitization, it has to be done. And if it's something that has to be allowed, it would have been reviewed beforehand by the developers or security engineers. So that's the point of trust types policies. Now that that has been said, what does the TT helper extension do? The first thing is it allows you to inject the trusted types header into your application. So for every request, or all the primary requests for the application are going to receive this header in report-only mode, which will initiate the process, I guess, of triggering violations whenever there is one. So whenever there is one of those dumb API call without a proper policy, a trusted policy, a violation will be triggered by the application. The next step is understanding where the violations come from. And that's where the TTL extension is going to be very useful. We're going to go through a set of screenshots that will show what basically the users of the extensions will see. And so the first one here is basically a view of the cluster that will appear. So there will generally be a couple clusters um, on the extension side where you can see a few information. So the first one is the root cause, as we said, of the violation. So where does it come from? Which script? Um, and so here in this case, it's a pretty common one from jQuery, which is a common source of violation. But it could be any library, a third-party one, or a first or a library which is directly used by the application. Along with that, you should see the violation count. So that's what's very confusing when you don't use that when you simply look at the console, I guess, is you might get 1,000 violation, but they all have the same root cause. Here they'll all group together, but it still shows you the count, which is irrelevant information. It sort of shows how widespread, I guess, the violation is in terms of calls in the application. The first time the evaluation was seen, so we can assume that the developer using the extension will just browse the application continuously, maybe for multiple days. So it's also worth noticing where it was detected. And finally, the violation content itself. So here, the violation type is the first information that you want to look at, and it shows this very clearly. So here it's an HTML violation, and that's probably again the first layer that you want to filter is what kind of DOM API are we looking for right now? And here, knowing that it's an HTML violation, you know that it's going to be something like an inner HTML or other HTML related DOM APIs that are used. So that's the first information you'll see. Then will come the script sample, which is one of our favorites, I guess, uh, trusted types inputs when it comes to the reports and I guess hints. The script sample is always available and it sort of shows you what got into the dump sync. So it will give you a quick hint on potentially whether this is a dynamic input, if it's static, is it part of your code base or an open source library? So that's a very useful information to have. And here again, you can see, I guess, the data evaluation. The script sample comes along with a few other fields. There's the document URL that will provide you, I guess, the location of the violation. So you want to potentially know on which page of the application you're facing it so that you can go back on that page, replicate it, and see it again. And then the stack trace, which will just basically give you a way to trace back exactly where it's being triggered and surfaced. And so you want to explore the stack trace um, to find out which line of code has to be refactored or fixed. And now comes the third piece that TT Helper helps to solve, which is the default policy part. The first thing is coming back on what default policies are for trusted types. And again, like it's not the most known, I guess, concept around trusted types in general. A default policy is basically a special trusted types policy, which has a reserved name. And it's a pretty powerful one. So what it does is it allows you to fix violations, every violation for a specific type, for example, HTML, all at once with one single policy. Um, and obviously, as you're fixing it, it allows you to apply potentially a layer of sanitization, which we highly recommend if we're talking about HTML. Or it could allow you to have like a strict allow list to only allow specific inputs to pass through. And that's the critical part of default policies, right? In terms of implementation, is you want to make sure that you get those things right. Um, so the sanitization layer has to be reliable. If you have a default policy with a weak sanitizer, all the trusted types work done is pretty much compromised in the sense that you might not see any violation anymore, but there is a way to bypass the default policy. And same with the allow list. If you allow one input, which could be potentially dangerous, it could allow an attacker as well to get a final access on the application. But beyond that, I guess what's tricky with default policies is you also want to make sure that you're not breaking the application by missing something. So for example, if you're not allowing something which is necessary on one of the main pages, the risk is to break a functionality for users. And I think that's also where it gets very tricky for developers, is finding the balance between those two things. And that's where TT Helper is trying to help. And the way it does it basically uses all the violations that it gathered on the other side to generate a default policy for you. So based on the data that it gathers, it does know what needs to be allowed for the app to be functional and which sanitizer can be implemented. So it's using safe sanitizers that we reviewed. It also allows the inputs necessary for the page to operate. One thing to mention though is it still requires a review from a security engineer, or somebody who would be able to, like, I guess, review whether those inputs are safe for the application, in the sense that we mostly focus on making the application. I'm not breaking anything. I'm not making any breaking change on the application side. There is still a chance that one of those inputs is unsafe. So there is still some, I guess, a human review required, but it completely shifts the paradigm. Like, in general, what happens is the security engineer has to go collect all the inputs, look at them together, and build the T policy. Um, from, I guess, scratch. Whereas here, only a review is required, and you're sort of guaranteed that it won't break anything on the application itself. So we believe that TT Helper will be very useful for developers. We're using it internally, and that it will be very useful externally. Um, but it's a runtime solution, and while they're great, they still have some drawbacks. One of them being that it obviously slows down the developer feedback cycle, right? They have to run things and merge them in staging, have or I guess, yeah, have the extension on browse themselves to get those feedbacks in, which is not necessarily the easiest thing to do, or at least I should say at that point the code is already merged in staging at least. Um, Sometimes the source mapping would also make it really hard to track the violations. So I guess, like, the information is necessary, right, to go back to the actual offending line is not necessarily there. And as, I guess, any other trusted touch related issue, the confidence, right, in the compatibility is always limited to test coverage. Um, if developers are unable to, like, browse through a specific part of the app, that should trigger a violation, and if the tests are not hitting it, the violation will just not be noticed until it hits the users potentially. So that's always a risk with that. And to avoid all of that and improve even more, I think what we want to do is to shift even more left. And that's where I'm going to let Guillaume talk about safety web, which aims to do that.